All right, welcome to Redgate webinar. We are going to talk about, whoops, what's going on? Come on, there we go. We're going to be talking about extending DevOps to the database, and we're going to be talking about branching and merging. Now, this is a monthly webinar series we've been doing pretty much nonstop, talking about automation, source control, release management, and all things DevOps, trying to move you guys into a much more DevOps way of thinking about databases. My name is Grant Fritchey. I do work for Redgate Software. This is my contact information. If you've got questions after today, I sure would appreciate you getting in touch. I've got a whole bunch of experience in the industry. I've been around for a while. I'm old, I have gray hair. That's really all you need to know. With me.
Hey, good morning, everyone. My name is Arneh Eskandari, and I'm a sales engineer here at Redgate. I've been with Redgate for 7 years tomorrow, actually.
Woohoo! Congratulations.
So thank you. So as part of my role, I work very closely with our either our existing clients or new clients who are looking at implementing DevOps within their database change management processes. And also I run a lot of trainings and webinars, and I'm really excited to be here with you guys today.
Okay. So we've got an agenda. We're going to go over a few things just to set stuff up, and then we're going to dive in and start talking about everything going on. Now, you guys are muted through the event today, but if you have questions, there is a questions panel built in, and you open that up and type your questions into the questions panel, and we will do our best to answer those probably towards the end of the session, but we'll see how it goes. So with that, we're going to go ahead and start moving through and get started. Redgate Software, if you're not familiar, just let me really quickly make you familiar. Redgate Software is a very large and successful organization. We've got a number of tools used by 91% of the Fortune 100 companies. We've been specializing in SQL Server tools, working with DBAs and developers for over 16 years. I bought their very first version of SQL Compare back in 1998. They're also big on supporting the community. You can go to SQL Server Central and get your questions answered or read articles. You can go to Simple Talk and read some fantastic, deep technical review articles. And there are just thousands of them on both sites, completely free, and you can get into it. Redgate also sponsors a lot of community events such as SQL Saturdays and Code Camps. Personally, I was just at SQL Saturday Orange County, where I did 3 different sessions, and I'm going to be speaking at SQL Saturday Philadelphia coming up shortly, and as well as next month SQL Saturday New York City. I'm looking probably at, I'm definitely looking at SQL Saturday Indianapolis, SQL Saturday in South Dakota, and it's not announced yet, but I think I'm going to be going back to Norway. We'll see what happens. Anyway, Redgate very much believes in community, and we support it. Let's see. Let's talk about this. Let's get going. Databases and DevOps. Now, it's fundamental that if you're really going to be doing DevOps, you're not simply doing development and applications. You are integrating databases. Databases are a fundamental part of most applications. And if you're not putting your databases into a DevOps process along with the application, you're missing the boat. And so what we're trying to encourage you now is to start saying that databases are a fundamental part of what goes on in any DevOps lifecycle, applications lifecycle management. The databases are directly there. It's not as easy to do database deployments, granted. Yes, the whole instance, the whole problem of maintaining the the information inside of a database inherently makes deployments more difficult. So it's not that you can't do DevOps, just that doing DevOps with databases does become more difficult. However, the criticality and the importance of the business information that's within databases actually enhances the need to move databases into a DevOps cycle, to move databases into DevOps methodologies, because DevOps methodologies actually are an added protection, are added facilities around protecting the information stored within your databases. So it's challenging, yes, but doing it is actually extremely rewarding. Now let's just talk about the issues that come up with databases, right? There's any number of things that happen. We get databases, that they're releasing on a different cycle from the application. People might release databases early, ahead of when the application releases. They might release databases after the application releases. There are all kinds of ways that do it, but what happens is if you're not releasing them in step, then you start to run into problems because you've got database code that's on version 1.1 and you've got application code that's on version 1.0 or 1.2, and troubleshooting that becomes more difficult than simply knowing that we're both on 1.1 and we know how things are working. Also, databases are frequently deployed with scripts that are manually run, or if they're not manually run, they're generated and run on the spot, but they're not done from source control the way application is, and therefore we don't have a traceability of the database changes. We don't know what changes we've made over time. The best you could do is go back and run compares against backups or something, but you don't know where the changes are coming from, what changes occurred, in what order they were done, and not having that traceability again makes troubleshooting extremely difficult. If there's issues or problems, understanding what they are and where they came from, which is the biggest part of fixing things, becomes extremely difficult. Also, without some type of change control, change management process, you run into, you can't roll back to previous versions of the database. Yes, absolutely, you can run a restore, but running a restore may overwrite data that's been collected since your deployment, and that could cause issues. So you're not necessarily going to want to run a restore. You're going to want to have some mechanism of a rollback on changes. That can be extremely difficult if your databases are not being deployed out of source control, if they're not being deployed through automated mechanisms. Also, when we start talking agile, if databases are, all done through manual processing, again, all done through, very careful, staged, very carefully controlled, very carefully managed, very carefully done manually processing, it becomes a serious bottleneck to agile processes. If we don't have mechanisms of provisioning our databases, of testing our databases, of validating the scripts in an automated fashion so that we can move quickly and safely, then we start to hit issues. We may do releases that are less frequent, and that's great, to a degree. From a DBA standpoint, a lot of us are very change averse. Change introduces problems, and I would much rather not introduce changes and therefore avoid problems, right? We want everything to stay online. But what happens is that then, instead of introducing 4, 5, 6 little changes, we introduce one big change consisting of 6 little changes. And then when things go wrong, it's harder to roll back, it's harder to recover, and it's harder to troubleshoot what's going on. Also, the more manual processes you have, the more difficult it becomes to do continuous integration and continuous delivery and automate all of your things. The more manual processes you have, the less automation you're doing. The more manual processes you have, the more opportunities you have for me, and I'm picking on myself when I say this, I will screw up your deployment if you give me the chance. So one of the biggest reasons ever that I automated a lot of the work that I've done for deployments and deployment management is so that I screwed up less. Because if I wrote the code and tested the code and validated the code, I could ensure that it ran correctly and it didn't require me to step through and do 15 things because we'd already automated it and tested that automation. So I mean, that's just all a big part of it. And then frankly, it takes a lot of hours to do manual deployments. It takes a lot of hours to do manual rollbacks if there are issues with the deployments. And so all of this makes database deployments difficult and also makes it more difficult to integrate databases into a full-blown DevOps process. And so we have to get past every single one of these issues. And one of the best ways to get past these issues, well, there's two steps to it. Step one is automation, and step two is getting some tooling that is going to allow us to walk through this process and get beyond it. Now, we've talked some about problems, but why are we trying to do this, right? What's the issue? Well, what we found is that DevOps for a database actually increases a lot of things. By making repeatable process, you've got predictability. You know how things run. You know what processes there are. You're eliminating manual processing from your activities, and we're ensuring that we know what's going to happen and when. We know where the code is coming from that's going to affect our database. We know how it was generated. We know all the methods that were used to test it. With all of that information gathered together, we've got more safety built into our database deployments. We know that we've got a repeatable process, we've got a documented process, everyone knows how it works, and we know how it's going to go out the door. That increases everything. Another thing it does is it enhances our speed. We're doing smaller units of change much more frequently and much more safely. Again, we've got that repeatable process. We know how it works. We know what's going out the door. Instead of some 10,000, 50,000 line script that's never been run anywhere before, we've got smaller change scripts, 100, 200 lines, maybe 1,000, but only 1,000. We make that small sets of changes, and those smaller units actually achieve higher degrees of safety, even though we're doing more of them, because each one is discrete, each one is small. We know that they're going out the door in a safe fashion, and we can get them out the door quicker. And then all of that provides for reliability. Once we've got a reliability, we've got automated tests. We know that scripts get run before they're run in production. Nothing ever runs on production for the first time. Everything is always run at least once someplace else, if not 10 or 100 times before it ever gets anywhere near our production server. Every single bit of this makes us faster, yes, which is huge. I mean, it's all about getting into DevOps, getting into Agile, but it also makes our databases safer. And to me, that's, as a DBA, yeah, I want to support my development team. Yeah, I want to do DevOps. Yeah, I want to move fast. But you're telling me that I can achieve greater degrees of safety for my production system? Now you've got my attention. Now I'm interested, right? This is what's going to drive me to champion this stuff, is not simply moving quick, but being safer. That actually I can get behind. Now, we've done a whole series of, what do you call them? Studies, interviews and whatnot, and we've put together a report, the 2018 Database DevOps report. And it's really interesting data. I love the fact that we collect all this survey information. Survey was the word I was looking for, by the way. I'm really glad we collect all this survey information so we find out how people are doing this, what degree they've implemented it. And the interesting thing is that within the next 2 years, 80% of companies plan to adopt DevOps. DevOps is coming. Even if you think it's not coming to your organization, it probably is. 80% of organizations are going for it. One of the biggest drivers is everyone wants to go faster. So that's why everyone else wants it. I want it because I know that it's safer. So it's, you know, I just keep that in mind. Yes, we want to go fast. Yes, we want to support the dev teams. But hey, if we're making our systems safer while we do this, let's do that. And then 76% of the respondents have developers in their team who work across both applications and databases, which is hardly shocking. I mean, it's pretty normal. And you guys can go and download the full report. You've got the link right there. It's very useful. We've updated this a couple of times now. We had one in 2016, 2017. This is the 2018 version. Things are changing over time. We're seeing a lot more adoption. We're seeing people in a lot higher degrees of maturity in their DevOps level. So the bottom line, the report found that IT performance correlates with practices such as version control and continuous delivery. Basically, if you're working all of your processing through version control and continuous delivery, you're probably a successful shop. It's just more or less they go hand in hand. Successful shops do this. Therefore, if you want to be a successful shop, emulate what successful shops do. High-performing IT organizations, they find, are much more agile. They deploy code much more frequently with a much lower failure rate and faster recovery from downtime. And all of this makes sense. And this is part of what I'm talking about with increased safety. Not only are we making the code go out, but we're making it go out more safe, in a more safe fashion, and we're able to do it while still avoiding downtime. That's just fantastic. And basically, if you've got a high-performing IT organization, you're twice as likely to make money. Let's face it, I want my business to make lots of money. It's not that I'm necessarily greedy. I am, but it's about making sure that my organization continues to be my organization. I support it in a way that it makes enough profit that it can pay me my paycheck so I can pay off my mortgage and keep my family, warm, dry, and fed, right? It's pure selfishness on my part, but that's why I want my company to succeed, so that I can do the things, that I'm supposed to do. So, with all that in mind, how can Redgate pitch in and give you guys a hand? Let's talk about it. We've got a suite of tools that get you from the moment you start developing to the moment you're deploying out to your production environment, and everything in between. And so if you're working on a system similar to this graphic here, where you've got database development going on, it's, you work on your code, it goes in and out of a source control system. You go through some type of continuous integration, and you'll notice all those tools down there that we plug into. We support Visual Studio Team System, we support TeamCity, we support Jenkins, Bamboo, Cruise Control, Go, and Hudson. I mean, this is fantastic stuff. You can go through release management processing, which allows you to move between environments, testing, QA, staging, financial testing, whatever additional processes you have. You can create an artifact, test that artifact on multiple environments, and then that final tested artifact, and when I say artifact, when I'm talking SQL Server, what do I mean? A T-SQL script. But we can take that tested artifact and get us out into our production environments. And we can do it through a process that supports testing at every stage and automation at every stage. So all of it goes through the DLM automation suite, so we can arrive at our production systems in a safe manner, faster and safer. I mean, I can't say safe frequently enough, because that's the goal. The goal is not simply to deliver software. As a DBA, my goal is to protect my production environment, which is why we have a SQL backup product, which is why we have a SQL monitor product, right? These are all DBA-focused tools. But the fact is DLM automation is also a DBA-focused tool. SQL source control is also a DBA-focused tool. These tools ensure added safety for my production environment. And so basically, we move you through development and operations all the way from the start to the end. Oh, I got detailed before I was supposed to. Oh, right. No, I did
Yeah, that's
not.
absolutely fine.
Yeah, no, I did not. I'm fine. Because what we're talking about today is development focused only. So what we're talking about today is branching. Um, Branching in a database is not easy. And I will just say that up front. It is quite difficult. But the whole idea here is that we're going to use our tools to create tables, create change processing, and now we can start to work on setting up continuous integration. Continuous integration allows us to do tests, lots and lots and lots of tests, so we fail fast. The whole idea here is to find what mistakes you've made in your code, and we all make them, me more than most, but we all make them. Find those mistakes early, find those mistakes quick through the continuous integration process. Once you've gone through the continuous integration process, you generate that artifact that I mentioned earlier. That goes through additional testing before anything goes out to your production environment. And that's the methodology that we want to step through. So, oh yeah, and there's our wonderful script. Alter table, create proc, and drop index. Let's hope that's all we have to do. With that in mind, I'm actually going to turn this back over to Arneh. He's going to walk you through how you're going to do branching inside your databases and how we can help.
Awesome. Thank you so much, Grant. Okay, so let me go ahead and switch to my screen here and share my screen. Okay, so hopefully everyone can see my screen. Just a quick reminder, so as we're going through the rest of the session, if any questions come up, please feel free to post them on the questions panel on your GoToWebinar panel, and we'll try our best to go over all of these questions towards the end of our session today. So for the rest of the webinar, what I'm going to do is to talk about how Redgate can help implement DevOps and best practices of source controlling, such as branching and merging against your databases. A very common question that I get from a lot of database shops that I work with is how do we cherry pick database changes that we want to push to higher environments? Cherry picking is a very common practice with databases, not a lot with code, because developers who work on application code are already familiar with the concept of branching and merging, and they tend to try to use that as much as possible to specify what's ready to go and what is not. With databases, since you have your change scripts that you can basically save and send off to a DBA and say, hey, can you execute these specific change scripts against our production or staging or any of the hiring environments, that basically makes it easy for you as a database developer to cherry pick and only send the change scripts of the changes that you want to go to production to your DBA or whoever the person in charge of your release management is. The problem with that process is that it's very error prone, right? So there's a lot of manual steps involved. You could easily miss change scripts or lose change scripts as part of that process and introduce drifts in different environments. And what that means is that when you're deploying to your testing or your staging, you may not actually be testing your deployment against a true copy of production at that point. So, and that kind of defeats the purpose of having a staging environment or a true testing environment. So what I'd like to do next is to talk about how we can utilize best practices of source controlling, such as branching and merging with databases. So instead of you having to cherry pick change scripts, you actually cherry pick your changes through source control, through branching strategies, and then you promote those up to your higher environments to be built and to be deployed. So let's go ahead and get started here. So the databases that I'm working with today is this VSTS Git AdventureWorks database. So we'll be using VSTS or TFS throughout this process, end-to-end process. both for source controlling as well as builds for validating our changes that we put in source control, as well as releasing our changes to our higher environment. So this is an existing project that I'm working on. So that means it's already in VSTS, and we have our code already in VSTS as well. So let's take a look at our files real quick. So this is our database structure, schema structure that we have in source control. As you can see, there's a subfolder for each class of object, and what we store in source control is the create scripts or the definitions of your objects. The nice thing about that is that if there is any conflict on specific objects between developers, or developers making changes to the same objects, then those conflicts can easily be identified, and it can easily be resolved. Whereas if you're just dealing with traditional migration scripts or change scripts, then there is no way that you can identify conflicts, because you're just adding files on top of files on top of files without any kind of relationship between them. So, so as a developer, the first thing I want to do is to get a latest copy of this code on my local machine, right? My machine. So this is a Git repository. So obviously the way that Git works is, you clone a copy of the repository down to your local machine, and then you commit your changes locally. When you're ready, you push those changes up to your remote repository or your Git server, where you can then promote to your build process and your higher environments. So what I already cloned a copy of this repository down to my local here. So my local repository is sitting in a folder here on my machine. So if you go ahead and take a look at that real quick. Okay, so here's my local repository that I've cloned. You can clone your repository using whatever Git tool that you're used to, whether it's the command line or Visual Studio or a Git client tool such as Source3, which is what I have here, and so on. So now that I have my local repository, my next step would be to spin up a database that matches the state of the database that is my local repository. So it's very important for you as a developer to be working with your local sandbox or your own copy of the database schema. Obviously, working with shared databases is a very common practice. One of the problems with that is that you can easily step on each other's toes before you even get a chance to commit your changes to source control. So things can get lost as a result of that. So it's very, very important that you try to move away from that shared model and provide copies of databases to individual developers so they can work in their own sandbox, especially if you're using Git, because the idea of Git is that you're working on your local sandbox, you're committing locally, and then you're pushing and sharing those changes with everyone else. So if you're starting off that process with a shared database, then you're kind of defeating the purpose of the whole Git workflow. So to do that, I'm simply going to spin up a new database here on my local. Let's call this VSTS Git Adventure Works Arneh. All right. And now using our Redgate tool, SQL Source Control, which is what you can see here in the middle pane here, I'm going to grab the latest copy of the database from my repository that I've cloned from my Git repository, and I'm going to apply that to my empty database that I just created. So let's go ahead and do that. What I'll need to do here, oops. That's strange. Let's disconnect real quick and try to connect to our engine again. All right. Okay, so here's the database that I've just created. My next step would be to link this database to that repository that I've cloned down from our existing project. So it's a Git repository. As you can see, we support different source control systems. So if you're working with a centralized source control system, whether it's TFS version control or Subversion or any other source control systems, you can easily go ahead and link your database to those repositories. So I'm going to go ahead and link it to my local here. Okay, and I'm going to go to the Get Latest tab here. As you can see, I'm currently linked to my master branch, and with Git, you obviously have the option to pull from the remote repository to your local to make sure that you're on the latest version of your code or your database in this case. So I'm going to pull from the remote to make sure I'm on the latest version. And as you can see, because my database is an empty database, it's just showing all the objects that I have on this database, including static data. So as part of our process, you can also source control your lookup tables, the data inside your lookup tables or your configuration tables. So here I have a couple of tables, address type, as you can see, and contact type, that are a couple of our lookup tables that we are source controlling. So every time we make data changes to these tables, those will be tracked alongside our schema changes. So let's go ahead and populate our database. As you see, you can see here, my database icon is now green. This is an indicator that the database is linked to my source control repository. The database is currently empty, so what I need to do now is to go ahead and apply my changes. Another thing to keep note of here is my current branch that I'm currently on. So master, I'm currently on master, so I'm grabbing the latest from master. And here you see as the tool will, in real time, it will apply those changes or create those objects to be more precise on my local development database here. All right, so I'm up and running with the latest version of the database with just a click of a couple of clicks of buttons. So now I can actually go ahead and start making my changes. So going back to our cherry picking story, so let's say that I'm a developer working in a team of developers. We're all working on different projects or different features that are using the same database. And these features are going out on different release schedules. So some of them are short-term features, some of them are longer-term features. So I need to have a way to specify, to kind of put my changes in a silo, and so that way when I'm ready to get, when my changes are ready to go, I can easily, merge those without worrying about all the other changes that were made by other developers too. So in order to do that, I'm going to create a branch in my repository. Again, you can do that using the Git command line or a Git client tool. In this case, I'm just going to use my preferred Git client tool, which is SourceTree, which is a free client tool provided by Atlassian. So going to create my new branch here. So let's call this RNA Dev. Okay, so created my branch, refresh my repository. Now you can see my database is pointing to my branch that I just created. So any new changes that I make to the database now is going to go into that branch to start with. And if I go to the commit tab here, we shouldn't have any new changes yet because we just grabbed the latest copy of the database. The only option that is giving me is to create the upstream of this branch. So in VSTS, I can get it to create the same branch that I created locally. So let's go ahead and do that. And then we'll start making changes to our database. So let's go ahead and start making some changes. So I'm going to start off by making a table change here. So here we have this person table. Let's say you want to add a column to this table. And here I'm going to touch on some of the features of SQL Prompt, which is one of our productivity tools that a lot of you might already be familiar with. So I just typed in AT and hit tab, and that auto-completed to alter table. That's one of the features of SQL Prompt, which is snippet management. So you can create your own snippets or use some of the built-in snippets that are provided as part of SQL Prompt. So let's go ahead and take a look at our table here. So I need to add a column to this table. As you can see here, I can easily see what columns are in this table, so I don't need to go back and forth between Object Explorer and my query window here. So we're going to add a new column to keep track of the LinkedIn username for our contacts.
Hey, Arneh.
Yes.
I've got a question that I can't answer, so I figured I'd interrupt you to answer it. What are the specs on your
Sure.
PC?
Please go ahead.
What are the specs on your PC? Because people are saying that they don't see it as fast as what you're doing.
Interesting. Yeah, it's a pretty it's not actually as
Yeah, I was going to say
powerful as some of the developer tools. So as you can see here, it's a standard processor with 16 gig of RAM, and yeah, nothing out of ordinary.
Okay, thanks.
So one thing that I've noticed with if we're talking about performance with SQL source control, especially working with Git, one thing that I find to be helpful is running SSMS as an administrator as opposed to a normal user. So for some reason that does speed things up a bit. So I'd highly recommend you to give that a try and see if that makes any difference. Okay, so let's go ahead and apply our change. So a lot of you, just like me, might be used to writing your code in a single line. So another feature of SQL prompt is to format if you want to. So you can utilize the formatting feature of SQL prompt to make sure that everyone's following a set style of coding, so that way things get committed into source control using the same style and using the same coding template, basically. So made a change to a table. Let's also go ahead and create a new store procedure. Okay, so let's call this get contacts. And let's get some data from our person table. So here you notice there are some green squiggly lines. This is actually another feature of SQL prompt, which gives you code suggestions. So this is basically static code analysis, making sure that you're following the best, following best practices. So for instance, here, if I hover over this, you can see that it's saying there's an asterisk in my select list, which is bad practice, right? So I can easily replace that. Or if you take a look at here, it says parameters that you've declared here are never used, so I can actually get rid of those parameters here. Or if I hover over create store procedure, you can see that it says store procedure starts with SP underscore, which is bad practice. So I would need to rename that. So the nice thing about this process is that a lot of these tests can also be ran automatically as part of your build process. So if as a developer, I miss some of these suggestions that are provided by SQL prompt, then my build would still fail. So let's say that if you just go ahead and stick to this SP underscore as for the name of our store procedure and see what happens when we get to the build side of things. So let's go ahead and at least replace our star with some columns here. And let's format our code and apply our change. And also finally going to make some data changes. So I'm going to insert a new record into one of our lookup tables that we are source controlling. So let's add a new type of contact. Let's call this lead developer. All right, so made a couple of changes here. So let's say we want to go ahead and commit these changes to source control. So simply right click on my database, say commit changes to source control. And as you can see here, it's showing me what changes have been made. So what we're doing here we're utilizing the engine of our SQL compare tool in the background to compare what's in our dev database versus what's in our source control repository. So for instance, here you can see with our contact type table, we've added data. So there's a new record. So it does a side-by-side comparison of the records between my table in the source and the table in source control, and it sees that there is a new record that has been added. If you take a look at our person table, again, we can see there's a new column that we've added. If you look at our store procedure, it's a new store procedure that doesn't exist in source control yet. So I'm going to go ahead and select my changes here and commit them to source control with a meaningful comment. Added a new contact type and made a couple of schema changes. So not meaningful enough, but good enough for a demo. So let's go ahead and commit. All right, so I've committed my changes locally into the RNA_dev branch. So now let's say that these changes are actually ready to go. So what I need to do is to now push them to VSTS or TFS. And my next step would be to merge those into whatever branch that represents your what's ready to go. So in my case, master branch is what I merge into for the changes that are ready to go. So I need to do that. Another great thing with Git is pull requests. Pull request with Git is very common when it comes to application code. So people do a pull request just to get someone to review the changes, whether it's a peer or a senior developer or a manager. That's basically up to you in terms of who should be the person reviewing those changes. When it comes to databases, it might actually make sense for it to be a DBA or someone who is in charge of doing reviews later on in the release management process. So so let's go back to our commits here. So here's the changes that I committed into my branch here. So next, I'm going to do a pull request to merge these changes into our master branch. So that way we can go ahead and validate those changes through a build process, run a set of automated tests against it, and if they all pass, then we can then promote these changes to our up the chain to our hiring environments. So just to quickly double check the things that we are merging. So the data change that we made looks good. The new store procedure that we added, as well as the new column that we added to our person table. So everything looks good. Let's go ahead and create this pull request. And in this case, no one needs to approve since I'm the only person here. So I'll just go ahead and complete the pull request and merge my changes into our master branch. So this way, if there's any other work that is going on by other developers, those changes will not be affected. So their changes will remain in their branches, but anything that you merge into master is what's going to get built and then deployed to your hiring environments. So as you can see here, our pull request was successful and complete. So that should have triggered a build on the build side of things. So let's go ahead and take a look at that. So here you can see we have a build definition and it's currently in progress. So while that's running, let me quickly walk you through our build process here. So as part of our solution, we make it really easy for you to get up and running with a build process or a release process or integrate your databases alongside your application code under the same CI/CD pipeline. So there are extensions, as you can see here in VSTS or even other build systems such as Jenkins, TeamCity, that makes it really easy for you to go in and define your build tasks for your databases. And here I'm using those extensions provided by our DLM automation component from our tool belt. So we're running a couple of steps here for our build. The first step is called build the database So what this is doing basically is it's validating the state of the database that is in source control by building the database against a temporary copy of the database. So you can either allow the tool to just create an empty database on a specific instance of SQL Server and validate your object against that empty database. So just to make sure that you don't have any invalid objects or any SQL Server syntax or compilation errors or issues with your database, you could even dedicate a specific database just for the build. So create a specific build database on a SQL Server instance, whether it's your dev instance or test instance, and use that database for the build purposes. In this case, I haven't specified a database, so we'll just go ahead and create a temporary database and do the build against that database for me. And finally, running the automated test. So as part of our tool set, you'll also have access to a tool called SQL Test. So SQL Test is a plugin to SSMS, as you can see, that has a couple of testing frameworks built into it. So the two frameworks are SQL Comp and TSQL-T. Both of these frameworks are actually open source and available out there for you guys to use for free. What we've done is we've built a UI around it, so you can actually easily add your databases to those testing frameworks through SSMS and be able to run your tests through the user interface as well, as you can see here. So if I go to my development database that I was working on, and you can see that in this database here, we have some objects starting with the SQL Comp schema and some objects starting with the TSQL-T schema. So these are the two testing frameworks. So SQL Comp is a code analysis testing framework, similar to the tests that we have built into SQL prompts code analysis rules that we saw earlier on. So these rules that are provided by SQL prompt can also be ran automatically as part of your build process. So again, if a developer misses, something, then the build process can catch it and fail your build as a result. So that's what we're doing as part of our second step. We're running these tests automatically against that build database and identifying any bad practices or issues with our database code. So let's go back to our summary and see what happened with our build. As you can see, our build failed. So let's take a look at it and see why that failed. So it looks like it failed on the test side of things. So let's see here. Let's go to our test tab. As you can see, we had a total of 38 tests, 36 of them passed, total of 36, 34 of them passed, 2 of them failed. And the 2 that failed here, we can see them here at the bottom. So a couple of issues have been found. So one is that we have a store procedure starting with SP underscore. And here we can see the name of the store procedure. Another issue apparently with that same store procedure is that our store procedure doesn't have set no count on as part of it. So which can introduce performance issues to our store procedure. So what I need to do now is to go back, make those changes as a developer. So the nice thing is about this whole process is that it gives you visibility now. So suddenly now you can easily see where your failures are, where these changes came from. So if I go back to the summary here, I can easily see that these changes came from this developer and from, in this case, it was actually from merge that happened into our master branch. So we can easily take a look at that merge and see what changes were made. So here we can see that there was a new store procedure and looks like the tests actually failed against that store procedure. So now I need to go back and fix the issues here and go through this process again. Okay, so let's go ahead and first of all rename our store procedure. So let's just call this USB underscore. So it's a user store procedure. And then the other issue was is that we don't have set no count on. So I'm going to add that to our data store procedure as well. Oh, let's do this. Okay, so made our changes here. Let's go ahead and commit those to source control again. So again, I'm committing into my dev branch here. So in this case, it's going to recreate that store procedure for us. Renamed store procedure. Added set no count on. Pushing our changes. Let's go ahead and merge again. Okay, so we can see what's changed here. So we've changed the name. We added set no count on. So let's go ahead and create this pull request again to merge into master. And now it's going to run through the build again. So as you can see, it's the process is very important. So if a build fails, that means you shouldn't continue with the rest of the process. You should always go back, fix your changes, run your build again. If it succeeds, then you can move on. So that way you don't move away from a working copy of your database or your code. So the idea here really is to basically treat your databases like code and follow all the best practices that are common on the application code side, but not so common on the database side of things. So let's go back to our build process and take a look at our build again. Okay, so let's go through our build again. And it's now running the tests. If the tests pass, then that hopefully our build should succeed this time around. And then we can promote those up the chain to our higher environments. Okay, so you can see our build was successful this time around because of those fixes that we made to the test that failed. So if you look at our tests, you can see that all of our tests actually passed. And you can see a list of all the tests that we had included as part of our SQL Comp testing framework into this process. So now my next step would be to quickly go ahead and release this to our higher environment. So I'm only going to release this to one of my environments just to give us a couple of minutes here to quickly go over any outstanding questions and also to wrap up our session, our webinar here today. So let's go ahead and take a look at our release. So just like the build extensions, we have extensions for the release side of things. So you can easily define your release process for your databases. So as you can see, the deployment to my testing environment has started. And if you take a look at my release process here, we've broken down our release into two steps. One is creating a release artifacts using Redgate extension, which is simply creating, running a compare between the artifact, which is actually a NuGet package, which is something I forgot to mention. So we build a NuGet package, which is basically the copy of the database from source control. And as part of the release, we compare the state of your database, which is basically what's in the master branch in this case, against our target environment to generate the update script and a diff report that shows what objects are being deployed and how. And then the second step is the execution of that update script that we generate as part of the first step. The nice thing about this is that you can introduce manual intervention between the two if you want to, especially for the higher environments such as staging or production. So someone can actually review this the script that is generated before it actually gets executed against any of your higher environments. So let's go back to our release summary real quick. As you can see, the deployment to our testing was successful. So what we do as part of this process is that we generate those artifacts that I mentioned. So let's go ahead and take a look at that. So we just deploy to our testing environment from release number 3. And here is the report that the tools generated for us. Okay, so as you can see here, there are 3 changes that it's applied. So the get contact store procedure, that was new, so doesn't exist in testing, so went ahead and added. As you can see, it's basically the final state of the object. So with the right name, with set no count on it. So we didn't have to create the store procedure and then go back and alter it, you know, if we were following a traditional kind of migrations approach. So we just take the final state of the object and we build it against the, you know, we synchronize the target to match that final state. Same with our person table. So we added LinkedIn as a column, and we also added a new record to our contact type table. So the nice thing about this is that, again, we're using compare. So those of you who are familiar with compare, you know, you can see that, you know, we have the compare warnings in here. So if there's any changes that could result into data loss, we can catch those and warn you about it. And finally, the actual deployment script, which is going to run in order to synchronize those changes over to the higher environment. So here's the alter table that adds our new column that we added. Here's the new store procedure that we created, and here's the data that we added to our table that are that have already been applied to our testing environment. So again, you know, visibility. So one thing that Grant mentioned earlier on, reducing risk, making this process safer. So this makes it really easy for you to be able to deploy faster, you know, have visibility into what you're deploying, what changes are going out to your target environment, and have the ability to review those changes before they even get applied to any of your higher environments. So I know we hit hour, so I'm going to stop right here and see if there is any outstanding questions, Grant, that you think we should address before we wrap up our webinar.
There were 2 related questions, and I'd love to hear your take on it. One was, sure, how can our tools help when they have environment-specific data, if I'm getting that phrase right? And the other was, what do we do about permissions that are different across environments? If you could.
Yeah, really good question. Yeah. So if you're talking about data, lookup data that is different from one environment to another, then first of all, there is no easy way to manage that. So you would have to either basically create environmental specific tables and then you know, for those specific lookup data, or use schemas and things like that to keep copies of the data different, you know, of the same data that are different for different environments, and then track those in source control. So we actually have an article that was put together by you know, one of my colleagues who is also an MVP, Alex Yates, which talks about some of these basically scenarios where you might have, data differences, or in some cases, the way that he's put it together is client-specific database lookup data. So the lookup data is different from one client to another, as opposed to being different from one environment to another. It's the same concept. So I will share that with you guys after this webinar, so you can take a look at that. And then permissions. So permissions being different. First of all, with our solution, there are certain things that you can ignore. So both through SQL source control, you can, if there's permissions are different from one environment to another, and you might want to basically exclude them. So you can actually apply, filter rules to exclude certain type of objects, such as users, such as roles, or you can apply specific comparison options to ignore permissions or grant statements within the definition of your object. So here I can go in and say, exclude users and roles, or I could go in and apply comparison options to say, ignore permissions, so those grant statements, or to ignore, there is another ignore option here somewhere. Yeah, I think that's it. So yeah, user permissions and role memberships, as you can see, is another option. So you can go ahead and ignore this, but the problem then is that any changes to permissions, you would have to then promote those, to your target environments manually. So what I've seen with different database shops is that the DBAs are normally in charge of kind of applying those permission changes and things like that. So you can either keep that outside this process, or if you keep it inside this process, then they will any permission changes in your dev environment can get promoted to higher environments as well.
Right. Okay, cool.
Yeah.
Well, let me switch back over here.
Yeah.
Nope, that was the last one. Let me switch back over to the slides. Let me show the right screen, I hope. Yeah, there we go. Get rid of the questions thing. Cool. Everyone who's still here, if you can, go to redgate.com/maturity-assessment and see how you guys are doing. Compare against your peers. You will get a full report with recommendations. Let's see, past that. And if you need any help, contact us at DevOps@redgate.com. Take a look at our full suite of tools and visit the Redgate Hub, which has got forums and stuff. So if there's any other outstanding questions and you don't get in touch with Arneh or myself, you can definitely go there to get your questions answered. So it's redgate.com/hub. And with that, Arneh, we are done for the day.
We are indeed. Yep, thanks everyone for your time. Hope you found this session useful. Again, the recording of this webinar will be available in a couple of days on our website, and we'll share the link with you guys through email.
Yeah,
thank you, Grant, for your time.
Sure, not a problem. Thank you. Great demo.
Thanks. And have a good rest of the day.
You too.